Hello everyone, in this video we're going to solve 2025 AP Calculus BC question 2. Alright, the curve C is defined by the polar equation of theta equals 2 sine square theta for theta between 0 and pi. The curve C and the semicircle are equals 1/2 for theta from 0 to pi, as shown in the figure below. Question A. Find the rate of change of the function with respect to theta at the point on the curve C where theta equals 1.3. Alright, so in order to find the rate of change, you need to take the first derivative, right? So we have theta equals 2 sine square of theta. Then prime theta equals 2 times 2 sine theta times cosine theta, right? Remember, you need to use the u to the n derivative. It could be n times u to the n minus 1 times u prime, where u equals sine theta, right? Now we're going to simplify this one, so it turns out to be 4 sine theta cosine theta, right? Now we substitute 1.3 for theta into this equation, so we have r prime of 1.3 equals 4 sine 1.3 times cosine 1.3, right? We print up the calculator, hit add calculator, so it's 1.031. Alright, question B. Find the error of the regions that lies inside the curve C but outside the graph of the polar equation r equals 1/2. Alright, so it's gonna be this guy right here. Alright, now first you need to find the intersection between two polar equations right here. The first one right here and the second one right here, right? So I'm gonna let this guy equals 1/2, right? So I have 2 sine square of theta equals 1/2, right? Now I'm gonna divide both sides by 2, so it could be sine square of theta equals 1/4, right? And then I'm going to take square root both sides, so sine theta equals plus and minus 1/2, right? So you have sine theta equals 1/2 and sine theta equals negative 1/2. For this one, theta equals pi over 6, and this one, theta equals pi over 6, right? That's it, because the domain is within 0 to pi, right? Now the error of the regions is calculated as 1/2, the interval from pi over 6 to 5 pi over 6. The top subtract the bottom, right? The top, which means the curve C right here. So it could be 2 sine square theta square, subtract the bottom, which means 1/2 square, right? D theta. Now we're going to use the calculator to solve this one. We hit menu calculus right here, number 2, and then right here we put pi over 6. Now you hit enter. The answer is 2.0667. Alright, let's move on to question C. It can be shown that ds over d theta equals 4 sine theta cosine square theta minus 2 sine q theta for the curve C for theta from 0 to pi over 2. Find the values of theta that correspond to the points on the curve C. That is farthest from the y-axis. Alright, just get the x and y coordinate right here. Now suppose there is a point on the curve C which is farthest from the y-axis, so suppose it could be right here, right? So I have the s coordinate right here, or it's right here, right? I have the s coordinate right here should be negative s, right? So if the distance from here to here is farthest, which means the absolute value of s must be maximum, right? In order to do that, you need to find the critical points, right? So we given the derivative of this one right here, right? So we let this one equals 0, right? So I have, I'm going to factor 2 sine theta out. So it turns out to be 2 cosine square theta minus sine square theta equals 0, right? Alright, now we're gonna bring up the calculator to solve this equation. Go to the main screen, right? And you hit graph right here. You input this function, right? Then you can hit enter. It's gonna be right here, right? Now we need to find the intersection. You know that theta from 0 to pi over 2. So you need to limit the domain, right? So I need to hit menu to window and window setting right here. It's gonna be 0, and this one as much right here, pi over 2, right? Pi, which means 3.14 divided by 2, it's gonna be 1.57 something, right? So I put 1.6. Alright, I hit OK. So it's gonna be right here. Now I need to find the 0 of this function, right? So actually the 0 of this function should be right here, right? So I hit menu, analyze graph, 0 right here. Move to the left of 0, move to the right of 0, the answer is right here. 0.955, right? Now we're going to use candidate test, right? So we have theta right here, and this is S R theta. This one actually R cosine theta, right? But R equals 2 sine square theta, right? So it could be 2 sine square theta times cosine theta, right? Now I have 0.955, and the last one should be pi over 2, right? Now what we need to do is to put this function on decimals, right? And then I have it right here. Now I need to calculate f of 0, f of 0.955 and f of pi over 2. So I just hit f of 0 right here. So I have three values right here, 0.769 and 0, right? So I have 0 here, 0.769 and 0. Now I need to answer the question. You need to say the value of theta that corresponds to the point on the curve that is farthest from the y-axis is 0.955. Now let's move on to the next question. Question D. A particle travels along the curve so that d theta over dt equals 15 for all time t. Find the rate at which the particle's distance from the origin changes with respect to times when the particle is at a point where theta equals 1.3. So it means that you need to calculate dr over dt given d theta over dt, right? So question D, we need to calculate dr over dt. Alright, so this one is the same thing as dr over something, right? This one dt. So now I'm going to put d theta over here, right? It doesn't change, right? Now I have or theta equals 2 sine square theta, right? So I'm gonna write it over here. Or theta equals 2 sine square theta, right? So I need to calculate dr over d theta. It's gonna be 4 sine theta times cosine theta, right? So I just substitute over here. It's gonna be 4 sine theta times cosine theta, right? Now d theta over dt is given right here, 15, right? So I'm gonna multiply by 15, right? Now I need to calculate dr over d theta. Evaluated at theta equals 1.3 equals 4 sine of 1.3 times cosine of 1.3 times 15, right? So I print up the calculator and hit enter. The answer is 15.465, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.